All right, guys, back at it. Let's see. Okay, so we're going to start working on some problems like this, where you're asked to take some trigonometric expression and simplify it. Okay, and there's a number of different ways to do that. One of the first ones you always want to take a look at is taking everything in the expression and either doing one of two things, either rewriting everything in terms of the exact same trig function, or rewrite everything in terms of sine and cosine. Okay, and this notion of rewriting everything in terms of sine and cosine works a lot of the time. Doesn't work all the time, but it works a lot of the time. Okay, so that's basically what we're going to take a look at today. Okay, so I have this expression right here, and I want to rewrite all of these trig functions in terms of sine or cosine and see what I can do with it. Okay, so let's see. Cosecant. Well, cosecant is the reciprocal of sine, so that guy right there would be the same as 1 over the sine of theta times secant. Okay, well, secant is the reciprocal of cosine, so that would be the same as 1 over the cosine of theta minus cotangent. We know is the reciprocal of tangent. Tangent is sine over cosine, so cotangent is cosine over sine. Okay, so I'm taking a look there and I'm thinking, okay, well, why not find, how about a common denominator and see what happens? Okay, all right, so let's see. So this guy right here is 1 over sine of theta, cosine of theta, like that. Okay, and so it looks like this guy has the sine, but it needs a factor of cosine there. So I'd have to take this cosine of theta over sine of theta and multiply above and below by cosine of theta. Okay. So it looks like our common denominator is going to be sine of theta times cosine of theta. And let's see, up above I would have a 1 from here. 1 minus cosine times cosine is cosine squared of theta. Okay. Now I take a look at that, that numerator, okay? And we go back to our Pythagorean identities, okay? And the most important Pythagorean identity is sine squared theta plus cosine squared theta equals 1. Okay, so I'm looking at this and I'm looking at that numerator. Couldn't I subtract cosine squared from both sides, okay, to manipulate this guy? And if I do that, don't I get sine squared theta equals 1 minus cosine squared theta? And isn't that this numerator here? So couldn't I substitute sine squared into this numerator? Okay, so this is the same as sine squared theta over sine theta cosine theta. And notice that I have common factor of sine in the numerator and the denominator. So if I cancel 1 down here and cancel 1 up here, I'm left with 1 factor of sine of theta up above. So all I'm doing is reducing a fraction. So I end up with sine of theta over cosine of theta. And we know sine over cosine is tangent. Okay, so this big expression reduces down to the tangent of theta. Okay, all right, I like that guy. All right. What do you say we approach this the same way as we approached the last one? Okay, so I've got to write secant in terms of sine and cosine. I've got to write tangent in terms of sine and cosine, and obviously sine is already in terms of sine and cosine. So let's see. Secant would be the reciprocal of cosine. So that's 1 over cosine of x minus tangent is sine over cosine. So that's sine x over cosine x times sine of x. Okay, so if I take these two guys and multiply them together, obviously I'm going to get sine squared of x over cosine of x, and then just bring this guy down. Now notice I didn't have to find a common denominator here because I already have a common denominator. So why not collect them? Okay, so I get 1 minus sine squared x all over cosine of x. And once again, just like the last problem, I'm looking at that numerator and I like that guy. Okay, so if we go to our Pythagorean identities, okay, and the most important one is sine squared of x plus cosine squared of x equals 1. And I need to have this 1 minus sine squared. So how about if I subtracted sine squared of x from both sides? Okay, I would get cosine squared of x equals 1 minus sine squared x. So that means this numerator right here is the same as cosine squared of x. So I substitute that in, and I get cosine squared of x over cosine of x. And then I can reduce it. Okay, so if I cancel off one factor of cosine here with one factor of cosine there, I still have a factor of cosine of x up above, and obviously I just have 1 down below. So this guy reduces down to cosine of x. Okay, so this entire trigonometric expression, okay, we can reduce down to cosine of x. Okay, I like that guy. Let's try one more. Okay. So it looks to me like this guy is already in terms of sine and cosine, and this guy is too. Okay, but I could do sine and cosine with cotangent. So let's see what happens. Okay, so I've got the sine of x plus, well, let's see, cotangent is the reciprocal of tangent. Tangent is sine over cosine. Okay, so cotangent has to be cosine over sine. Okay. Okay, so I'm thinking like this. Okay, what about that guy like that? Okay, so I would get the sine of x plus I'd have cosine squared of x all over sine of x. Okay, well, this is like sine of x over 1. So just like the other two problems, why not find a common denominator? Okay, so I would have to multiply above and below here by sine of x. Okay, so I take sine of x times sine of x times, that's sine of x over 1. Okay, plus I have this cosine squared of x over sine of x. Okay, so it looks like sine times sine, so I'm going to get sine squared of x over sine of x plus cosine squared of x over sine of x. And adding them together, I'm going to get sine squared x plus cosine squared x all over sine of x. And look at that numerator. Pythagorean identity. The most important one again. Sine squared x plus cosine squared x equals 1. So that means this numerator has to be equal to 1. So we get 1 over sine of x. And of course, 1 over sine of x is the reciprocal of the sine of x, which is cosecant. Okay, So that guy simplifies all the way down to cosecant of x. But going back here, and these are always good ones to take a look at, notice how it depended on a Pythagorean identity. As a matter of fact, the most important Pythagorean identity. Okay, this guy depended on the most important Pythagorean identity, and so did this guy. Okay, so this, Pythagorean identity, especially the first one, which is the most important one, because the other two Pythagorean identities are derived from that one, which we did. Yeah, this guy comes into play all the time. So keep that guy front and center in your mind, okay, when you're taking a look at these kind of problems. Okay, short video for today. I'll be back again tomorrow for another one. You guys stay safe, and I miss all of you.